In this video, I'll be covering problems 36 through 40 on practice test number 2 in the math section of the ACT practice booklet. Problem number 36 says, which of the following equations expresses C in terms of A for all real numbers A, B, and C such that A cubed equals B and B squared equals C? So A cubed equals B and B squared equals C. So they want C in terms of A, so you need C equals A to the something. So what I would do is plug this A cubed here in for B, because it gives you that B equals A cubed. So then you'd have A cubed to the power of 2 equals C, which is A to the 6th equals C, which is answer F. Next, problem number 37. So this problem says, after visiting Florida State University during spring break, Francisco rents a car for 2 days to travel around Florida. He has $225 to spend on car rental for the 2 days. Seahorse Car Rental charges $50 per day and 25 cents per mile. Ocean Blue Car Rental charges $60 per day and 20 cents per mile. Which company, if either, allows him to travel more miles for the 2 days, and how many miles more? Note, taxes are already included in the rental charges. So what I would first do in this problem is I would set up an expression for the two companies to solve for X, or the miles traveled from each car. So let's start with Seahorse Car Rental. So Seahorse. So he has $255, so 255 equals, so they charge $50 per day, so 50 times 2 for 2 days, because it says he has 2 days to travel around, plus 0.25 per mile, and I'm just going to call X the number of miles here because that's what you're trying to solve for in this problem. So now let's solve for X, and I would use my calculator for this. So you'd have 255 minus 50 times 2, and then that divided by 0.25. So that would be 620 miles. And then next, let's do Ocean Blue. So here you would have, so he still has $255. Then you would have 2 times 60, because they charge $60 per day, plus 0.2x. So then solving for x, you get x equals 675. Or 675 miles. So you can see that Ocean Blue allows him to travel for more miles, and if you subtract these two, you'll get by 55 miles. So then the answer is B, Ocean Blue, and allows him to travel 55 more miles. Next, problem 38. In the standard XY coordinates plane below, the points 0, 0, 10, 0, 13, 6, and 3, 6 are the vertices of a parallelogram. What is the area in square coordinate units of the parallelogram? So I'll just draw the parallelogram out really quickly here. So that would be 3, 6, 13, 6, and then 10, 0. Okay, so the formula for area of a parallelogram is the area equals base times height. And the reason for that is you don't really need to know this, but it's kind of interesting. A parallelogram is made up of 2 triangles, and the area of a triangle is 1/2 base times height. So if you add the two together, you'll get that the area of a parallelogram is just base times height. And so it looks like the base here is 10, and then the height would just be this, which is 6. So it'd just be 10 times 6, which is 60, and that would be answer G. Okay, next problem. So this problem says, for every pair of natural numbers n and m, to which of the following sets must n plus m belong? And then I think for this one it's easier if I'll read out the answers. So 1, the natural numbers, 2, the integers, 3, the rational numbers, 4, the real numbers, and 5, the complex numbers. So this one is kind of hard to do if you don't have prior knowledge of this. So to help us out, I'm just going to draw kind of diagram here to explain this. So it's kind of weird, but not making it very good diagram. So inside here, these are the natural numbers. And then here are the whole numbers, or also known as real numbers. I'll put that there. And then here are the integers. And then here are the rational numbers. So from this diagram, you can see that the natural numbers are like the smallest segment, the smallest thing of numbers, smallest set of numbers correctly, and they're encompassed by all of the other sets of numbers. So for something to be a natural number, it must also be an integer, and it must also be a rational number, and a real number, and a complex number. So therefore the answer is E. N plus m must belong to all of these sets of numbers, and this is just because the natural numbers are the smallest set of numbers, so the other sets must encompass it. And now problem 40. A certain perfect square has exactly 4 digits. That is, it is an integer between 1,000 and 9,999. The positive square root of the perfect square must have how many digits? So for this one, what I did is I just thought of an example in my head. So let's say like 1,600 would be a perfect square. So then the two numbers that make up this perfect square would be 40 times 40. And 40 has 2 digits, so the answer is G for that one. And if you try to test this with other ones, it would also always work, because the number that you multiply has to be the same, and this number has to have 4 digits, so they each have to have 2 digits. So, and then just some general tips for this section would be, always just know how to use your calculator and know how to plug in numbers to that, because I always use that on a lot of these problems. And then another one tip would be you can always guess and check if you're not sure which one of the answers you would pick, because the ACT doesn't deduct points for guessing, so it's always a good bet just to pick an answer even if you're not certain that it's correct. And then another tip would be, like we did on problem 37, know how to set up linear equations and expressions like this to solve for a certain variable. Like, for example, we solved for how many miles you could travel on each car, just because this will make a lot of these problems easier. You could do a lot of them without knowing this, but it just makes them go faster, and because the ACT is such a time-pressured test, you'll need to go as fast as you can on this. And then just one more tip would be to, if you're not sure about what a question is asking, like number 40 could be kind of confusing about the perfect squares having exactly 4 digits, and how many digits does the positive square root of the perfect square have. In situations like this where they're giving you a general case and you're trying to find another general thing that follows this case, it's really helpful. What I do is I just think of an actual number that fits into what they're asking you. Like in number 40, I thought of 1,600, and then see what you would get doing what they ask you to do on that number, and then apply that, because it's a lot easier to do that than to, well, at least for me, it's easier to do that than to think through what they're trying to ask you.